This question is about reactions of iron compounds. Part A. A student carries out the reactions in the flowchart starting with iron 2 sulfide. Part 1. In the boxes, write the formula of A and B. Firstly, let's write our reaction for this part of the flowchart, where our pale green solution is reacted with chlorine. So what we're going to have is FeH2O 6 2 plus Cl2, and that's going to produce FeH2O 6 3 plus 2 Cl minus. Now we need to balance the equation by having a 2 and a 2. So what we've done is we have oxidized our iron. Then what we're going to do is we're going to react FeH2O 6 3 plus with 3 OH minus, and that is going to be the ligand that is substituted to form FeOH3 plus 6H2O. So our precipitate is FeOH3. Then we need to work out what we're going to produce as precipitate B, which is going to be this reaction, and that is H2S plus 2AgNO3, and that produces Ag2S plus 2HNO3. And we can check using the information in the question that the molar mass of the precipitate B is 247.9 grams per mole. So that would be 107.95 times 2. That's the relative formula mass of silver times 2, plus 32, which is the relative formula mass of sulfur, and that equals 247.9 grams per mole. So we can then confirm that this is the correct formula for the precipitate and write it in the answer box. To get the 2 marks for this question, you get a mark for each correct formula. Part 2. The student thinks that the reaction of iron 2 sulfide with H plus H2O is a redox reaction. Explain with reasons whether the student is correct. In a redox reaction, one substance is oxidized and one substance is reduced. But in this reaction with iron 2 sulfide and H2O, or H+, the student is incorrect, and the reason for this is because the oxidation numbers don't change. So if we looked at iron 2 sulfide, that is FeS. So iron has a 2 plus oxidation number, and iron also has a 2 plus oxidation number in its pale green solution. So the reasoning behind this is because no oxidation number change. So we could give an example to support our answer, and the example could be that iron, or Fe, is always plus 2. So to get the mark for this question, you need to say the student is incorrect because no oxidation numbers change. The example is not part of getting the mark, but it's important, if you can give an example, to give an example, because it reiterates your point and confirms to the examiner you know what you're talking about. So it's always a good idea. Part 3. Write the equation for the reaction of FeH2O6 2 plus aqueous with Cl2 gas. So this question, we are asked to rewrite our answer for part 1, or part of our answer for part 1, which is the purple equation that I've written. So if we rewrite that here, that would be 2 square brackets FeH2O 6, 2 plus Cl2 goes to 2 Fe H2O 6, 3 plus 2 Cl minus. So to get the mark for this question, you need to have the full, complete, correct equation. Part 4. Construct an equation for the reaction of H2S gas with H plus aqueous MnO4 minus aqueous. So firstly, let's write our reactants. We're going to have H2S plus MnO4 minus plus H plus. And we're going to produce Mn2 plus S plus H2O. Then we need to balance the equation. Balancing the equation, we would have 5 H2S, and so we need 5 S and 8 H2Os. And then we're going to have 2 MnO4 minuses, which means we need 2 Mn2 pluses. And balancing our H pluses, we need 6 of them. So for this question, you get a mark for having the correct equation, and then you get a mark for balancing the equation. Part B. Compound C is a hydrated ionic compound with the empirical formula FeH18N3O18. A student investigates the thermal decomposition of compound C as outlined below. Stage 1. The student gently heats 0.003 moles of compound C to remove the water of crystallization. 0.486 grams of water is collected, leaving 0.003 moles of anhydrous compound D. Stage 2. The student strongly heats 0.003 moles of compound D, which decomposes to form a solid oxide E, with the molar mass of 159.6 grams per mole, and 270 centimeters cubed of a gas mixture measured at room temperature and pressure containing gases F and G. Stage 3. The student cools the 270 centimeters cubed gas mixture of F and G. Gas F is a compound that condenses to form 0.414 grams of a liquid. Gas G remains and has a volume of 54 centimeters cubed measured at room temperature and pressure. Gas G is tested and it relights a glowing splint. Determine the formulae of C, D, E, F and G. Show all your working and equations for the reactions. Firstly, we need to highlight the key piece of information in this question. Our first key piece of information is the empirical formula of compound C and its moles, and then the mass of water collected, which is 0.486 grams of water. So using the equation triangle of mass divided by moles times the relative formula mass, we can work out the moles of water. So that would be 0.486 divided by 18. 18 is the relative formula mass of water, and that is equal to 0.027 moles of water. So we can compare this to the moles of compound C. So we've got 0.027 to 0.003. That's a 1:9 ratio. So that means we've got 9 waters. So using the empirical formula, compound C is going to be FeNO3 times 3.9 H2O. So the anhydrous version, which is compound D, is going to be FeNO3 3, because that's if you take away all of the water. So moving on to stage 2, the key piece of information firstly is the molar mass of E. So we can use this to work out the formula of E, and it gives us the formula of Fe2O3. If we check this using its relative formula mass, that would be 55.8 times 2 plus 16 times 3, and that equals 159.6 grams per mole, which is what we've been given in stage 2, so it matches, and that is the formula of E. So looking at the other key piece of information to find the formula of F and G, we're told that it's a 270 centimetre cubed gas mixture that's measured at room temperature and pressure. We've got 0.414 grams of gas F when it condenses to a liquid, and 54 centimetres cubed of gas G, because it remains a gas. So we're going to use the equation of volume over the molar volume. So the molar volume for centimetres cubed is 24,000 centimetres cubed, and that equals moles. And then we're going to use the equation triangle to work out the relative formula mass of gas F. So that would be 270 minus 54 divided by 24,000, and that gives us 0.009 moles of gas F, or of F, because it's not a gas, it condenses to a liquid. But using these moles and the mass, we can work out its relative formula mass. So that would be 0.414 divided by 0.009, and that equals 46 grams per mole. So that is equal to NO2 as the gas F. So that's F, because if we were to check this, we would have 14 plus 16 times 2, and that equals 46. So finally, we need to work out what G is. We're told that G relights a glowing splint, and this is the test for oxygen. So that's what G is. To get the marks for this question, it's a level response question, so there aren't specific marking points. But what the criteria is that you need to reach a comprehensive conclusion to determine the correct formula of almost all of C, D, E, F and G, and that you have 9 waters. There must be a well-developed line of reasoning which is clear and logically structured.